7.6 is solve exponential and logarithmic equations. And the properties of equality for exponential equations is if b to the x power equals b to the y power, then x equals y. And for logarithmic equations, if log base b of x equals log base b of y, then that means x equals y. So if you have an exponential equation, the goal is to get the same base. And if you have a logarithmic equation, you want to condense and isolate. So number 1, we have the base 7 to the 3x plus 4 power and base 49 to the 2x plus 1 power. We want the bases to match since this is an exponential problem. And we can change 49 to 7 squared. So on the left, this won't change, and 49 is 7 squared. And on the right, we can distribute that too, so that'll be 7 to the 4x plus 2. Now, since the bases are the same, that means we can set the exponents equal to each other. So that'll be 3x plus 4 equals 4x plus 2. And then to solve, we can subtract 3x, and we'll get 4 equals x plus 2, and then subtract 2. So we get x equals 2. And you don't have to check unless it's a log problem. So log only for the checking. And since this is an exponential, we don't have to check. Okay, number 2, we have 10 to the 3x minus 10 equals 1 over 10 to the x minus, or 6x minus 1. So we want them to be the same base. I'll choose 10 as my common base that I'll use for both. So I don't have to change the left. And 1 over 10 is 10 to the negative 1 power. So again, I'm going to distribute the exponent on the right. So that'll be 10 to the negative 6x plus 1. And now that they have the same base, we can set the exponents equal to each other. So 3x minus 10 equals negative 6x plus 1. And then we're going to solve for x. So we get 9x minus 10 equals 1. Add 10, and we get 9x equals 11. Divide by 9, and we get x equals 11 over 9. Okay, number 3. We have 7 to the 3x power equals 18. This time we can't get them to have the same base, but to kind of bring that power down, we can use log base 7 on both sides. So then, okay, hold on, I'll write it out so you can kind of see it. 7 to the 3x equals log base 7, 18. So then now this part will cancel out because they have the same base of 7. So that means 3x equals log base 7 of 18. And get x equals log base 7 of 18 over 3. So I would plug this into the calculator. For log base 7 of 18, we would use the change of base formula. So log 18 over log 7, and then we'll divide the whole thing by 3. Okay, so then we'll get x equals 0.495. Okay, number 4. First we want to isolate the exponent. So we're going to subtract 4 on both sides. So we have 10 to the 2x power equals 5. And then we're going to log both sides. So kind of similar to that last problem. So then that way the base of 10 will cancel out and we're just left with 2x. So this will cancel and we get 2x equals log 5. Divide by 2 and we get x equals 0.349. And I chose log base 10, which is just log, so that the 10 will cancel out. Okay, number 5. We have log base 5 of 12x minus 11 equals log base 5 of 3x plus 13. Since they both have log base 5 and nothing else, we can just set the insides of the parentheses equal to each other. And then we're going to solve for x. So that would be 9x minus 11 equals 13. So we get 9x equals 24. And we get x equals 8 over 3 when we simplify. So now, since this is a log problem, we have to go back and check. We have log base 5 of 12 times 8 over 3 minus 11 equals log base 5 of 3 times 8 over 3 plus 13. So that'll equal 48 minus 11. 8 plus 13. Oh, oops, sorry, not 48, 32. Okay, so that would be 21. Okay, so it does equal, so that means this is our answer. Okay, next one, we have ln 3x minus 10 equals ln 4x minus 5x. So again, since they don't have anything extra and it's just ln equals another ln equation, we can set them equal to each other. And then solve for x. So I'm going to add 5x to both sides. Get 8x minus 10 equals 14. 8x equals 24. And we get x equals 3. And since it's a log or ln problem, that means we do have to check. So we have ln 3 times 3 minus 10 equals ln 14 minus 5 times 3. So we have ln 9 minus 1, oops, sorry, 9 minus 10 equals ln 14 minus 15. Ln of negative 1 equals ln of negative 1, which is correct. Okay, so for this one, we have log base 2 of x minus 4 equals 6. To get rid of the log base 2, we can use an exponent or a base of 2. So we're kind of moving up the original problem as an exponent, and then this will cancel out. So we have x minus 4 equals 2 to the 6th power, which is 64. And then if we add 4, it's 68. So we get log base 2 of 68 minus 4 equals 6. Of 64 equals 6. And that's going to be true. Oh, I should have done this in purple, but this is the checking part. And then that's going to be 2 to 6 equals 6. So this is true. Okay, And then for this last problem, we have two logs, so we want to condense those first. So this would be log base 6 of 3x times x minus 1 equals 3. Then to get rid of the log 6, I'm going to use the base of 6. Those will cancel out, so we have 3x times x minus 1 equals 6 to the third. So that'll be 3x squared minus 3x equals 216. And we're going to get a quadratic, so we have to move them all to one side and solve. So I'm going to subtract 216 on both sides. Get 3x squared minus 3x minus 216 equals 0. We can factor out a 3, and we'll be left with x squared minus x minus 72 equals 0. We do the x method, it's negative 72 on top and negative 1 on the bottom. So that would be negative 9 and positive 8, and x goes on top. So this is 3 times x minus 9 times, x plus 8 equals 0. We're going to set each one equal to 0. And solve. So we get x equals 9 and negative 8. Okay, so we have two numbers to check, 9 and negative 8. Okay, so that'll be log base 6 of 3 times 9 plus log base 6 of 9 minus 1 equals 3. So that's 27 plus log base 6 of 8 equals 3. We can combine those by multiplying. 27 times 8 is 216. And this is true. So that means negative 9 works. Or sorry, positive 9 works. Okay, and the other one we have to check is negative 8. So that would be log base 6 of 3 times negative 8 plus log base 6 of negative 8 minus 1, and that would equal 3. So we get log base 6 of negative 24 plus log base 6 of negative 9 equals 3. And the numbers would be out of the domain because 6 to no power would equal negative 24. So this one doesn't work. So that means 9 is our only answer. Oh, and actually, this one, since it makes the number inside the parentheses equal to a negative number, this is actually going to be no solution. Because when we plug in 3, that would make the inside equal to negative 1. And if you remember, for the graphs, the domain has to be greater than 0. Because if we look here, this means e to what power would equal negative 1, and that's not possible. So this would be no solution.